Hello. So the idea of this short video is because sometimes I don't have enough time to cover all of the examples that I have. So right now we're going to be covering this part of segmenting with gradients, which can be quite important with some of you, especially with people working in transmission microscopy or DIC. So you should have already installed the EMBL plugin that is described in a few slides before. And then in there, if you go into EMBL samples, then you're gonna find something called DIC cells. Okay, this is gonna download the image from the web and it's gonna leave it like this. And if you're gonna be playing with this a lot, I recommend that perhaps you go file, save as TIFF, and you save a copy on your desktop. Okay, so then it's easier for you to just reload things after this is done. Okay, so now the problem with an image like this coming from DIC is that you see that there is this shadowing effect from, let's say, from the north to the south. What happens then is that classical thresholding algorithms will have a lot of problems, because if I do image adjust threshold, you will see that if I try to threshold the lighter parts of the image, I can do something fairly decent for the upper part of my cell, but not for the bottom. And if I were to say, okay, this is the opposite, then you will also end up in similar situations where if I segment from the opposite, the shadows, then I don't manage to catch the upper parts, right? So this is going to be very annoying to fix up. And then the method that I'm going to show you is a method which is based on gradients. So a gradient basically measures the difference between pixels that are close by. So where you have a very strong change, like in this border, then we should have a strong gradient. And here as well, we should have a strong gradient. And the gradient will be positive in both cases if I want to. So for example, here, if I go into gradients, you will find that there is something which is called gradient 3D. You can select that one, you can run it. You can use it as is common default for use calibration. You say, okay. And then now what you will see is that now you have an image that is showing you what is the gradient of that original image. Okay. Now you will see that in this implementation of gradient, there is a small problem here on the edges. Okay. So what we could do is that we could just take this guy and we could remove that small region where, when the gradients are not really valid. This is just an edge effect. So I can also go in here, I can say edit selection, restore my selection. So I have both exactly with the same ROI. And then I do, for example, edit, and then I do a crop. Where is the crop? Image crop here. And then I go here, image crop. All right, perfect. So now I don't have that effect and they're both exactly the same size. Okay, you see that here the dimensions are exactly the same. Right, so then what would be my next step? Well, my next step now is to do a thresholding algorithm. So image adjust threshold. Now you see that I'm interested in an image with a dark background. And in this particular case, I've been playing a little bit around. I know that the Lee algorithm works well, but of course you can try different methods and see the one that best suits your particular image. Okay, let us stay with Lee, and then we see apply. Okay, now once we are here, what happens is that we have to do what is called morphological operations. So that's the next slide to make this even better. So there's a morphological operation that is called image close, which is going to try to fill small gaps between segmentations. So the easiest is actually just to show you. So if I click on close, and you have to look for this one, process binary close, and I run it, you see that we have managed to actually connect those little components, let's say, of the segmentation that were a little bit far away from each other. Okay. Then the next thing that I can do is I can fill holes. This is another binary operation. What it's going to do, as the name indicates, is going to fill holes inside big islands of pixels. And then finally, we might want to remove those little, pixels that are outside. And for that, instead of a close, I'm going to use an open operation. Okay. And then I say run. And then you see now we have a very decent segmentation of that sum made out of gradients. And just to show that it's working, we can do edit selection, and we can make selection, create selection, sorry. And then we can go to the original image and we say edit selection, restore selection. All right. Now you see that the segmentation was quite successful.